In the worksheet that you guys did for homework for today, you had to find the values for the trig functions of the angles, but if you noticed, they were all the first quadrant, right? Like they were all, 30, 60, 90, and so on. In order for us to now venture out and do the same thing for the other angle, for any old angle, we first have to talk about what a reference angle is. Okay, so here's how we define a reference angle. First of all, a reference angle is an acute angle. What does that mean, acute?
Smaller than 90.
Smaller than 90, greater than 0, right? So it has to be between 0 and 90 degrees. So it can't be 0 and it can't be 90 either. So a reference angle is an acute angle, and it lies between the terminal side of an angle and the nearest x-axis. Okay? And we use it to find the values of the trig functions. Okay? For any angle. And the symbol for it is theta prime. That's what we call it. So if theta is the angle, then theta prime is set to be the reference angle.
What's terminal side?
Terminal side. So I'm going to talk about here. So terminal side is when you open up your angle, that last side of the angle. Right? So like this is initial side, terminal side. Okay. So when you have an angle, it's going to be in one of the four quadrants, right? Unless it's a quadrantal angle, it's going to be in one of the four quadrants. So let's go one by one. Suppose your angle is in the first quadrant, like this. So boom, boom, right? Okay. What's a possible measure? So suppose this is 50 degrees. In this case, there is no reference angle. It is its own reference angle. Okay? Now, suppose you have an angle in the second quadrant. So let's say, suppose my angle is 100 degrees. Okay, that's my angle. Okay, I just said the reference angle is between the terminal side and the nearest x-axis. So this is the terminal side. And then the reference angle is between the terminal side and the x-axis. So from here, I need to go to the x-axis. Now I could either go to the right and go to the x-axis or the left. Which one is closer? The left. So that is my theta prime. Okay? So it has to go from where your angle finished to the nearest x-axis. That's theta prime. So in this case, if the blue is 100, how much does that leave for the red? How much? 80, right? 80. So this whole thing here is 180. If the blue is 100, then that leaves 80 for theta prime. Okay? Now, take a look at this angle here. This one. Right? Suppose now I have an angle which is 200 degrees. I need to first locate the reference angle. It goes from the terminal side to the nearest x-axis. Again, I could either go to the right or the left. Which one's closer? The left is closer. So now I need to figure out how much that is, right? And the book tells us all these formulas, but we don't want to do that. And I see a lot of you guys are mouthing 20. Yeah, because until the other, here it's 180. And then how much further did I go to make it 200? 20. So theta prime is 20. Okay, here, suppose now I have an angle of 300 degrees. My theta prime is going to be from the terminal side to the nearest x-axis. So I say to myself, had I gone a full circle, that would have been 360. but I only went 300, so how much more do I need to go? 60. Right? So do you see how we find reference angles? Okay, every single book gives these formulas, and I always think, okay, should I put them in the notes or should I just not put them in the notes? But then you know what? To make a point, I put them in the notes just so I have you cross them out, so that whenever somebody says, hey, look, there is a formula, you tell them no, because I can reason it out. I'm not going to memorize any formula, okay? Just reason it out. It's much easier. Okay, so here we go. This is a type of a question you'll get. Sketch each angle and give the reference angle in degrees. Okay, we could do that. Let's draw an angle of 330 degrees. We're experts at that now. So here we go. 330 degrees is somewhere over there, right? Okay, now you need to draw where the reference angle is. That's this one. How much is it? 30 degrees. So theta prime is 30 degrees. That's exactly what we did, yeah. Because I think to myself, this would have been 360, but I only went 330, so that's 30. Okay, here we go, one more. 152.5. Because angles could be in decimals. Okay, what quadrant does that fall in? 1, 2, 3, or 4? 2. Somewhere over there. All right. Theta prime is this little itty bitty one. So I think to myself, had I gone all the way to the other black horizontal line, that would have been 180. But I only went 152.5. How much is the balance? Okay. So if I do 0.5 more, it'll be 153, and then I need 27 more. Yeah. Okay. All right, so 152.5, if I add another 20, it's 172.5. And then another 7.5, that gets me 180. Or you can use your calculator too. Okay. Okay, here. Negative 240. Okay, now we're going in the negative direction, right? So let's see. That goes from here. Negative 90, 180, 240 is there. Now, where is the reference angle? It's between the terminal side and the x-axis right there. Never the y-axis. In trig, the y-axis is like, we don't care about the y-axis, okay? So right there. So now here's how I do this. How much was this part, the blue? 180. How much more did I go to make it 240? 60 more. So theta prime is 60. Always positive, always between 0 and positive 90. Okay? So from here to here, it was 180. But I had to go until I reached 240. So I went 60 more. Now I have negative 800. So this is going to be a little bit of a, maybe we need our calculators for this one. So go ahead and take out your calculators. Negative 800, right? Okay, so I go 360, right? How much more do I need to go? If I go another 360, now I've gone 720. How much more do I need to go? Another 80. So I'm here. Theta prime is this one. How much is that angle? 80. Okay? All right. Now, this is in degrees. Let's go and, yes.
How come on the negative 240 it's not just like raised to 270?
Because we never look at the y-axis.
Oh,
The y-axis is like we don't care about the y-axis at all.
okay.
Never. Doesn't exist. Don't care about him. Yep. Okay. It's all about that the x-axis in this case. Okay. Radian measure. Believe it or not, finding reference angles in radian is 100 times simpler than in degrees. Because in radian, the reference angle always looks like this, pi over something, where a is the denominator. So you look at the angle that you're given, right? 4 pi over 3. Now, is 4 pi over 3 reduced all the way? It's reduced, right? You can't simplify it anymore. So the reference angle is just pi over this denominator. That's it. Pi over 3. That's it. There's no thinking. There's no calculating. Nothing. Huh? If it's, so 4 pi over 3 is simplified. Yeah. So this one here, 21 pi over 6, you're like, oh, trick question. Nobody simplified it. If I do simplify 21 pi over 6 and I divide by 3, I get 7 pi over what? 2. Oh, so this should be pi over 2, not 3. Okay? All right. So let's do this one. 14 pi over 6. What can I simplify by? 2. So I get 7 pi over 3. So what's the reference angle? Pi over 3. That's it. That's it. Okay? So you wouldn't say pi over 6 because it hasn't been simplified. Okay, negative 5 pi over 4. Is it simplified? Yep. What's the reference angle? Just pi over 4. Always positive for reference angles. What about this one? Can we simplify? By 7, we get negative 5 pi over 6. So theta prime is pi over 6. And what's theta prime for D? Pi over 3. Okay? Huh? Because the reference angle is always a positive angle from 0 to 90. Okay, here, for each angle, we need to do a couple of things. Find the corresponding reference angle and state the quadrant in which the angle is located. So, let's draw 500. I start from here. I go 360. How much more do I need to go? 140. So right there. Okay, so my angle is located in quadrant 2. And now the reference angle theta prime, it's this one. So I went 360. And then I went 140 more. How much is left for the red? 40. Okay? All right, go ahead and do B, C, and D. You might have to simplify C, right? So go ahead and do B, C, and D. I'll pause this for a minute. Okay, so C, what quadrant is it in?
3.
And the reference angle?
Pi over 6.
Pi over 6. D, what's the reference angle?
30 degrees.
30 degrees, and it's in quadrant 2. Okay? For each one, I would like to see the arrow for the initial side, terminal side, and your rotation. Okay, now we're ready for the biggie.
Wait, do you have to show the graph?
So the directions for this says, well, I guess it doesn't ask for you to draw them, but it does say, yeah, that's fine. So, but it does say to find the reference angle and state the quadrant where it's located. And on the test or quiz, I'll ask you, like, it'll be, okay, like reference angle, quadrant. And so if you can visualize what quadrant it's in, fine. But if you have to draw it, then, you know. Okay. Now, we're almost at the point where we can figure out, you know, like, let's say, tangent of any random angle. All right? But there is one more piece to the puzzle. So in order to figure out these trig values, it's 3 steps. One is find the reference angle, and now we're experts at that. Okay? Second is evaluate the value for the reference angle. This second step is what you guys did on the homework yesterday. Okay? Then determine the SIGN sign. So plus minus. All right? Yeah, the sign of the sign, the SIGN. Right? So is it plus or minus? Okay. The way we do that is there is this, you know, mnemonic. It says all students take calculus. Have you guys seen? Some of you have heard that before. All students take calculus. Okay, so here's how it works. All students take calculus. Okay, so it doesn't have to be a correct statement because the one for PEMDAS, right? What's the thing for PEMDAS?
Please excuse my dear aunt.
Yes. Or there's another one with eggplants. You guys know that one? Purple eggplants make delicious afternoon snacks. So clearly these sentences don't have to be true. So we could use all students take calculus, okay? Okay, so what does this mean? This is the one, okay, so it's all. This is the quadrant. So if an angle lands in this quadrant, whether you take sine, cosine, tangent, it's all positive. Listen. Okay. If an angle lands in this quadrant, only the sign of it is positive. The rest, if you take a cosine in this quadrant, it's negative. Tangent, it's negative. Then, T for take, T for tangent. In this quadrant, only tangent is positive. Everything else is negative. And in this quadrant, C for cosine, cosine is positive. Everything else is negative. So here's what I mean by that. Suppose I have an angle that looks like this. Okay? That's in quadrant 2. Now, if I asked you for sine of that angle, would it be positive or negative? Positive. If I asked you for tangent of that angle, what would it be? Negative. Okay? Now, the other piece to it is, we talked about sine, cosine, tangent. Well, what about secant, cosecant, cotangent? Secant goes with cosine, so if cosine is positive, so is secant, and so on and so forth. Let's do some examples, and that's really the best way to do it. Okay, here we go. This is it. This is like the finale, right? This is where we've been heading this whole time. Okay. Tangent of 5 pi over 3 is what I need to find. Okay, so first step is find the reference angle. So number 1, find the reference angle. In this case, it's pi over 3. Second, it's evaluate the value of the trig function for theta prime. What does that mean? That means I'm being asked to find tangent. I find the reference angle, and now I need to find tangent of the reference angle. Okay, is this exactly what you did in the homework last night? Tangent of pi over 3. You did 20, not 26, 30 of these, right? You did 30 of these, okay? So now we know tangent of pi over 3 is the opposite, right? Okay. Tangent of pi over 3 is the opposite over the hypotenuse, root 3. Okay? That's what you did on the homework last night. The third step is figure out what quadrant the original angle is in and see if it's going to be positive or negative. So where is 5 pi over 3? That's 5/3 pi, which is 1 2/3 pi, right? So 1 2/3 pi, fourth quadrant. Tangent is negative there. So finally, my answer is negative root 3. This part. Now, it says here, determine the SIGN sign, right? So, you look at your original angle, 5 pi over 3. You have to draw it and see what quadrant it lands in. So, 5 pi over 3 is 1 2/3 pi. In mixed number, this is 1 2/3. So I go, okay, 1 pi, and then another 2/3 pi. Now I'm in quadrant 4, right? Okay, quadrant 4, all students take calculus. Is tangent positive here? No, cosine is. That means tangent is negative. So I say, I already knew that it was root 3. Now I know it's negative. So I combine, and it's negative root 3. It does seem like this long process because I explain it in pieces. Eventually, it becomes quicker and quicker and quicker. But again, how do we get there? Lots of practice. I was telling one class the other day, like if I think back to how many of these I've done since I was in high school until now, I was like, maybe it's like 500,000 of them, right? You guys have done 10. So obviously, when I do it, it's going to be like, oh my God, like it's going to seem easy. But when I had only done 10, was it that easy for me? No. I had to like really go step by step by step. When you do 500,000 of them, you'll be even better than me. Okay? So let's do this one. 150. What's the reference angle? So you can draw it at any point in the process. You know what? I'm going to draw this first. 150 is here. What's the reference angle? 30. So now I'm being asked to find sine of 30, right? And so if I only draw one of these triangles on my page, that's good enough, right? I can refer to it anytime. What's sine of 30? 1/2. Next, I need to figure out this angle 150 lands in which quadrant? 2. In that quadrant is sine positive or negative? Positive. So finally I put 2 and 3 together and I say my answer is positive 1/2. Obviously, if it's positive, you don't have to write the plus. You get the idea. It seems doable, no? Yeah. You just have to make sure to stay positive, not lose like faith. Just go in steps. And don't listen to other people who say, oh my God, trig is so hard. Like, don't listen to them because it's clearly something that we could all do. Okay? All right. Cosine of pi over 4. Reference angle? Pi over 4. Okay? Okay, so cosine it's gonna be, okay, so this is the pi over 4, which is the other triangle, right? In fact, maybe if I draw one of each on the board, it's easier. So it's 1 over root 2 on each side. Okay. Cosine is how much? 1 over root 2. What quadrant is this in? It's in quadrant 1, meaning cosine is positive or negative? Positive, because everybody's positive in the first quadrant. So finally, my answer is 1 over root 2. Okay, I'm going to do sine of 120 with you guys. Then you guys are going to do the other 4. So let's do sine of 120. First, I need reference angle, theta prime. I have a 60. What else? Does anybody think differently? Any other answers? Okay, we're going to go with 60. If you have trouble, draw it. 120. Reference angle is that one. So that's 60. Okay? Next, I need to find sine of 60. Right? Sine of 60. 30. Root 3 over 2, 1/2. So what's the sine of 60? Root 3 over 2. In this quadrant, is sine positive or negative in the second quadrant? Positive. So the answer is just root 3 over 2. Now, you guys are going to do EFGH. And you can work either alone, or if you would like to bounce ideas off of somebody else, you can talk to the people sitting next to you. EFGH. Let me pause this for a little bit. Positive root 3. All right. Anybody want to do G and H? You could do them over there. Oh wait, I already had volunteers. G, and I have a volunteer for H. You could do it in that space over there as well. Yes. Tangent, yes.
Oh. Oh.
So okay. Right, so the last one is in the fourth quadrant, meaning it's positive 1/2. E is positive root 3. secant of 5/3 is positive 2. And G for tangent is negative 1/√3. Okay? Fabulous. So, the homework for this is from the book. It's right over there. It's on page 219. So this is D period. This homework is due when? Tuesday. Tuesday, you'll also be turning in all of the homework from this week. We will review in class on Tuesday, and your test will be on Wednesday. Fabulous. Okay.